here is a rule whose outcome actually is a bit surprising, and in fact it's so surprising that it even fooled Leibniz. Leibniz got this product rule wrong the first time he did it, then of course he quickly corrected himself. But what is the product rule? Well, in the product rule, as the name says, we're looking at what is the derivative of a product. And so the rule goes like this. If we have a function which is the product of two pieces, f and g, two factors, then its derivative is going to be a sum. Is the sum of the derivative of one function times the other, and the derivative of the other function times the first. And of course, it doesn't matter in which order you make those products and additions. Okay. Now, this one also requires a proof, but this one is so interesting and involves a little mathematical trick that you should understand properly, and so we're going to do that one in class. Quotient rule, same thing. So the quotient rule is probably the most complicated rule that we're going to use. We're going to see some methods of differentiation that are more complicated than this. But as a rule, the quotient rule is the most complicated one. And I'm sure you have seen this formula before. So the derivative of a quotient is given by that difference on the top and the square or the function on the bottom. Hold on a second, I'll tell you in a minute how to remember that one. Now again, I'm not going to show you the proof for this one either. We're going to see both of these proofs in class. In fact, for the quotient rule, I'm going to give you two different proofs in class. Okay, but I'm going to give you two mnemonics to try and remember how the product and the quotient rule work. Now, I have to say this mnemonic is not my own invention. I was told it was told to me by a colleague of mine who teaches in high school, but I find it can be very effective if you like it. If you don't like it, too bad. Alright, so for the product rule, there are two mnemonics actually that you can use. Remember, the product rule says if your function is a product of two pieces, the derivative looks like that, fg prime plus f prime g. And a little jingle that goes with that, and it says 1d2 plus 2d1, calculus is so much fun. And the rhyme works. Okay, so you do the first function times the derivative of the second plus the second function times the derivative of the first, and that's what you get. Okay, but remember that I said that it doesn't really matter in which order we do the product or the sum, so we can also do it differently. We can say that the derivative is going to be f prime g plus fg prime. That's actually the formula I gave you earlier. Well, there is a little jingle for this one too, and it goes 2d1 plus 1d2, calculus can be fun too. And again, as you can read it, we do the second function times the derivative of the first plus the first function times the derivative of the second. And the other ones are just to make sure that we get the rhyme. Now, for the quotient rule, that's interesting because the quotient rule has its subtraction in the numerator. And so that means that we cannot really invert anything. We have to be careful on how we prepare the whole fraction. And so in fact, the jingle here is done in such a way that it can only rhyme in one way, okay? And it goes like this. If you have, first of all, remember if we have a quotient, the formula for the derivative is that one, f prime g minus g prime f over g squared. So the thing to remember is low d high minus high d low, draw a line and square below. You may have noticed I had a second of hesitation because, again, with these mnemonics, they may work or they may not work. So what does this say? Low function times the derivative of the high, low d high, minus high d low, so the top function times the derivative of the bottom function. Then we draw a line, the fractional line, of course, and we square below. Now notice that if you switch those low d high and high d low, then you're lost with the second line. The rhyme will not work, and that will remind you that the other direction does not work. So once again, I mean, if you like mnemonics and if you think this method can help you, great. If you don't, and if you prefer to stick with formula, just as well, as long as you make it work. Now we only have one more little topic related to differentiation rules that I want to show you, and that is the chain rule, and then we're going to be moving into differentiation methods.